Assalamualaikum warahmatullahi wabarakatuh. My name is Farhana Binti Mohd Radzi, and I would like to present my proposal defense for undergraduate project 1, which is the title for my project is Geospatial Approach for TNB Asset Mapping using mobile LiDAR data that was supervised by Associate Prof. Sr. Dr. Muhammad Zulkarnain Abdul Rahman. So this is the presentation outline that divided into 10 sections, which is introduction, problem statement, aim and objective, study area, significant study, research scope, literature review, methodology, expected result, and Gantt chart. Alright, so we move to the introduction. What is TNB asset? So TNB asset include pole, overhead cable, transformer, feeder pillar, customer's meter, and etc. for customer use are pinned down on digital map by using the method of data acquisition, which is mobile laser scanning. It captures geospatial data usually equipped with a combination of GNSS, Global Navigation Satellite System, photographic, radar, laser inertial measurement unit, IMU, 3D laser scanner, and camera. MLS has many applications that can be performed, for example, utilities mapping such as light poles, telecommunication poles, overhead cables that are crucial necessity in the local industries such as TNB, Telecom Malaysia, and etc., which are typical kind of road infrastructure. Okay, next. Alright, for the problem statement, most utility companies try to use the geospatial method approach for asset detection mapping, and MLS is also widely used for work involving asset mapping because of the conventional method is extremely time consuming. In addition, the field crew also face different safety issues in the field, especially when maintenance work is carried out. So, to overcome this issue, an effective and flexible survey method is needed. Hence, this research will come out with these two issues, which is issue number 1, conventional manual methods of surveying are extremely time-consuming, and issue number 2, conventional electrical asset inspection and maintenance rely primarily on manual field survey, which are financially expensive and operationally inefficient. Therefore, towards the end of this research will contribute to produce good result of high density point and point cloud data using geospatial approach for TNB asset mapping using mobile LiDAR data. So to make sure this research is on the right track, the aim for the research is at employing geospatial approach for TNB asset mapping using mobile LiDAR data in Taman Sri Pulai, Johor. So the objective of the research is divided into 3, which is to collect high density point cloud data using LiDAR equipment at Taman Sri Pulai. And then second objective is to extract TNB assets from point clouds using machine learning approach, and third, to validate the result obtained from extraction of TNB assets with the data collected in the field. And then, alright, so for the research question, how can this mobile LiDAR technology be useful to the local industry, especially for TNB, and what are the workflow, challenge, and benefits of the TNB asset mapping using mobile LiDAR data? Therefore, from the research question stated, it will guide this research until the end. And then next, for significant study, it will give the benefits for local industry by providing accurate asset location, And then the detail of asset information and network connectivity, which will enhance the TNB services. It also can be employing to the different of application for TNB services. For example, land use land cover mapping purposes, terrain mapping, asset management, and it also gives benefits to other agencies that related with root assets such as Telekom Berhad, Indoor Assets Management, Plus Berhad, Jabatan Kerja Raya JKR, Jabatan Ukur dan Pemetaan JUPAM, and other agencies involved. So next. So this is the main study area for this research is located in Taman Sri Pulai Johor, which is in Peninsular Malaysia as shown in a map. So this study area was focused on suburban area located in Taman Sri Pulai. Therefore, for the data collection was taken from this covered area for TNB asset, which is utility pole and overhead cable. This area selected as one of the study area because as we can see, the mixed use or residential area is representing the land cover. Hence, there is a lot of TNB asset, especially electrical pole and overhead cable as one of the contribution or sources to distribute electrical power to users. Moreover, these areas are easy to access because it located in road environment which are important roadway assets. So for this study area, as we can see, there were 6 ground control points along with Route 1, Route 2, Route 3, and Route 4 that assumed as 4 main routes that covered on this study area that using mobile LiDAR equipment for data collection by using vehicle, and apart from that, the inaccessible area such as Road A, Road B, Road C, Road D, Road E, and Road F are using backpack camera to capture the TNB assets. Yes. And then the total area for this study area was approximately in 2 kilometers. So next. So this is the example of TNB assets that exist around residential areas, which are pole, substation, overhead cable, feeder pillar, and customer meter. So this is the research scope of the research project that consists of data sources and feature extraction. For the data sources, all data only use mobile LiDAR data, and ground truth data only collect for the location of the asset pole and overhead cable. And for the feature extraction, there are several TNB assets. For example, switchboard, customer meters, feeder pillar, overhead cable, and pole. But in this research, we only focus on extracting overhead cable and poles. So for the literature review part, this is the outline which consists of introduction, LiDAR technology, that consists of airborne LiDAR, terrestrial laser scanning (TLS), mobile LiDAR scanning, which has characteristic of mobile laser scanning, characteristic of mobile LiDAR point cloud, and then electricity utilities asset management, feature extraction using mobile LiDAR technology. On this feature extraction, we divided into several subtopic, which is pole extraction, overhead cable extraction, machine learning method approach for point cloud, statistical approach for point cloud classification, and then electricity asset detection using mobile LiDAR data, and summary. So we move on to the LiDAR technology, which is mobile laser scanning. MLS data has high density and high accuracy is now becoming a primary of highway mapping, urban road distress, assessment and inventory of road features. So mobile LiDAR equipment, unlike their unborn, mobile LiDAR equipment, unlike their airborne counterparts, have the following benefits, such as grid view of the pavement, direct overview of vertical surface, such as facades of building projects, and then closer to the ground objects, higher point density such as 4,000 points per meter square with traveling speed of 50 km per hour or higher of vehicles and visible from the roadway. So as is known as mobile mapping is one of the methods of collecting geospatial data from a mobile vehicle and also a backpack method for covering of roads and inaccessible area. So for the utility pole, this part will explain for the pole extraction, which is utility pole is one of the TNP asset which is important in the asset management and play crucial role in overall electricity management. A new approach for the extraction and classification of pole-like structure using mobile LiDAR, point cloud data with scan lines and GPS time information was proposed by Fukano and Masuda. So based on findings, 5 steps were suggested by Ibrahim and Litchi to detect road poles from terrestrial laser scanning data, and then using 2D based segmentation, they first arrange 3D point clouds and then remove vertical objects. Then using area growth, vertical pole-like object was separated from the segmented 2D object based on centered based horizontal distance analysis. Segment belong to the object is combined, and the last one is Cartesian describe pole detection algorithm, which is also use profile scans and use pole sweep information in successive profiles. Points were grouped based on the distance between neighboring points along each profiles, and collected sweeps were clustered by comparing sweeps from the consecutive profile to form the pole. So for the overhead cable extraction, Guan described there is a few steps need to be taken for extracting the overhead cable lines from mobile LiDAR data. First, by adding elevation differences and slope parameters to road range and scan line by scan line. This approach calculates our road range with respect to incidence angles and distinguish of road points from road surface points. Then there are 3 filters are proposed to extract power transmission line or power tower points from the define of road points in terms of height, spatial density, and a combination of size and shape, followed by the extraction of individual power transmission lines via half transform and Euclidean distance clustering. And finally, as a horizontal line is in the xy plane and a vertical catenary curve described by a hyperbolic cosine function in the xz plane, a 3-dimensional 3D power transmission line is modeled. So for the summary, nowadays many companies do mobile mapping near abroad for asset extraction, but in Malaysia, it is still lacking, and many assets close to the trees and so on make it a challenge in mobile mapping in Malaysia. In addition, for Malaysia users, many conventional methods are as stated in the uh, problem statement. Therefore, uh, from this finding, it will help TNB to make semi-automatic feature extraction or method in any other feature extraction in this research. So we go to the methodology part. In this methodology flow chart, there are 4 phases that consist of data acquisition, data pre-processing and feature extraction, accuracy assessment, and the last one is produce the final result. Each of the phase following by the objective number 1, objective number 2, and objective number 3. So we go through each of the phases, which is for data acquisition. There will be 2 types of data, which is mobile LiDAR data and ground truth data that categorized as urban and suburban data. While for data pre-processing and feature extraction, this research will be going through all of the process starting from georeference data, filtering the noise and feature extraction. And for the feature extraction part, we will use machine learning method that use random forest algorithm, which is focused on feature extraction for pole and feature extraction for overhead cable. In the phase 3, accuracy assessment will be conducted after the feature extraction has been done. To validate the result, we use error metric or confusion metric based on the classification of point cloud to identify the accuracy of data. And the last phase is focused on the final result, which is to produce map based on the location of pole and overhead cable, whether in 2D or in 3D. Towards the end, there will be 5 expected results from this research, which is extracted point clouds of poles, extracted point clouds of overhead cable, accuracy assessment based on error metric, which is confusion matrix, and then comparison between urban data and suburban data, and also the last one is the NB assets map. So this is the progress work for this undergraduate project, which is followed by proposed research title, proposed research synopsis, preliminary study, developing research proposal from chapter 1 to 3, rewrite, review writing for chapter 4 and 5, and then proposal correction, prepare for data processing, data validation, utilizing for data asset extraction, and development of research proposal for chapter 1 until chapter 5. So based on the current date at this stage, my progress work are at proposal correction and will do the data processing at the same time. So that's all. Thank you.